I'm going to come back to this example of a conical tank, and we're going to add more detail to it this time. So we're talking about, in this case, water draining out of a conical tank at 4 cubic centimeters per second. The base of the tank has a diameter of 6 centimeters and the tank is 8 centimeters high. Determine how fast the height of the water in the tank is changing. So just like always, we're going to write down what we know. All right, we're given water is draining out at 4 cubic centimeters per second, so we will have to recognize that that's dV/dt. And I made it negative since the water is draining out. The water in the tank is becoming less and less as time goes by, so the rate of change is negative. And I've also made note of the dimensions of the tank itself are 6 and 8. 6 for the diameter and 8 for the height. All right. The unknown, they're asking us to find dH/dt, how fast the height of the water is changing, when the height of the water is 5. Okay, so just like always, we want to draw a picture. All right, I'm going to label these d equals 6. Now, keep in mind I'm talking about the diameters of the tank itself, of the conical tank. All right, not of necessarily the water in the tank. And in the initial example earlier on, we talked about how if we took the derivative of this formula for volume, we differentiate with respect to t. So we have to use the product rule here, and we would get an expression or an equation that looks something like this. Okay. Now, I'm given dV/dt, so I'm happy that that is in that equation. I'm trying to find dH/dt. I'm happy that that is in the equation. But dr/dt is something that I don't directly, at least, know anything about. We can figure that out. We're given the height, and we can figure out dr/dt as it relates to dH/dt, and we can figure out the radius at a given time. But I'm going to suggest a different way of approaching these problems, and here's what I'd like you to think about. Any water that fills this tank is going to take on a shape which will form a triangle that is similar to the triangle defined by the tank itself. Right? So no matter how much water is in the tank, it's going to take on the same diameter or radius to height ratio as the original tank itself has. Okay, so I'm going to take this equation. I'm going to use the fact that my diameter is 6, so that means 3 over 8 is equal to my radius over my height. And therefore I can solve that for r as 3/8 h. And I can plug that in for this r here as 3/8 h. So r squared becomes 3/8 h squared. Now, think about why I might want to do that. I'm given dV/dt. I want to find dH/dt. So this r is kind of the odd man out. Right? It's sort of a middleman that I'd rather not have in that equation. If I make this substitution 3/8 h, I can get this equation just in terms of v and h. Right? And that is a good thing. It's going to make my life a lot easier. Keep in mind that this relationship between r and h is going to vary depending on what the original size of the tank is. So it's not always going to be 3/8 h. We're going to have, sometimes we're going to have a conical tank, sometimes we're going to have a certain relationship when it comes to cylinders or right triangles. So we really have to think about this in terms of the unique geometric situation of the problem itself. But in this case, we have this relationship between r and h, and we can make that substitution, and then we have to simplify that. So remember, we cube the square the 3, square the 8, and we square this h, and this h squared multiplies by that h. I get h cubed. All these constants, the 3 squared, the 8 squared, the pi over 3, they simplify out and sift out into 3 pi over 64. Now I have a really easy derivative. So I'm going to take the derivative of both sides. I have dv dt. This is all just one big constant, so it stays in front. I take the derivative of h cubed. It's 3h squared dh dt. Again, I do a little bit of simplifying. I take this 3, multiply it by that there. So I have this constant now. And I have a really pretty simple expression for dv dt equals 9 pi over 64 times h squared times dh dt. Now I plug in my current constants, right? So I know that dv dt is -4 throughout the course of the entire problem. They want me to find dh dt when h equals 5. So I plug those in, then I just solve for dh dt. You could have your answer in either one of these forms. Though for this to be correct, I need a negative there. You can leave it in terms of pi, a reduced fraction in pi, or you can use the decimal. If you use a decimal, leave 4 decimal places. So that's a good example of kind of a more complicated related rates problem. You should spend a little bit of time thinking about that and maybe rewatching the video until you really understand what's going on there, and then bring questions you have to class with you next time we meet.